Okay, here we go, 11.3, and this is the back side of your notes. The front side looks like yours is all nice and filled in. On the back side, let me just walk you through these three guided practice problems from the book, and I'll help you. These are complicated, so let me walk you through and hang in here with me. Now, if you think or what I would recommend is pause the video now and try these, or at least this first problem, number 3 here in the back. So the more that you lift the weights yourself, the stronger you get. If you just sit there like a lazy bum and all you're doing is just writing as fast as you can to get this stuff on the paper, it'll be of no value. Zippo, blanco, no value to you. So please exercise your brain and try to do as much as you can, and then allow me to come around and help you and explain how to do it. Here we go. They want us to find the perimeter and the area of a regular polygon. Perimeter, you remember, is P, which is perimeter, equals N, which is the number of sides, S, which is the length of one of the sides. And then the area is 1/2 A, remember A is apothem, times the perimeter. So first thing we do when we have our polygon here is, what I would do is draw or make sure that a central angle is drawn. In this case it was not. So going from the center to a vertex, we draw a radius here. And now you can see between these two radii, that is your central angle. Now in order to calculate that central angle, you need to know how many sides. So you count them up. So n equals 5. Remember, 5 is the number of sides. It's also the number of angles. So this is gone with 5 sides. And the length of one side, we'll call that S. So in order to calculate this central angle, remember you take 360 degrees, the total number of degrees in a circle, and divide it by the number of sides, or in essence what you're doing is dividing it by the number of triangles that you have here in this regular polygon. Again, remember, regular means that it is equilateral and it's also equiangular. So this is a unique polygon. So 360 divided by n, in this particular case, it is n equals 5. That's a 5, not an S. I make my 5s like an S sometimes. So 360 divided by 5 equals 72 degrees. And then, remember how we do this? We take this triangle now, the right half of it, and blow it up. Make it big so we can be able to see it. So here's my larger, the small right triangle, and I know this length here is 8, and that's the radius, because that's going from the center to a vertex. That's 8. And then they tell me that the apothem going center to the side at a perpendicular angle, the apothem is 6. So let me label that as apothem. And what's left over here on the other side of this triangle is going to be, we'll call that x, is half of the length of the side. I've not calculated the length of the side yet, but I do know that x is going to be half of that side. So when in order to find out what the measure of this angle is at the top of my right triangle here, I take 72 and divide it by 2, and that's 36. So I can write in there now that this is 36 degrees. So this is what I know about this triangle that I've written down here. And again, I want to find the perimeter and I want to find the area. Now, for me to be able to find the perimeter, I'm going to need to know what x is. And once I find what x is, then I can multiply that by 2 in order to get the length of the side. Once I get the length of the side, then I can multiply times n, and that'll give me my perimeter. So to be able to find x, I notice first of all that this is not a special right triangle, because this is 36 degrees, so it's not a 45, 45, 90, nor is it a 30, 60, 90. what I need to do is use trigonometry. And I want this side, which is the opposite, so I could even label this in reference to the 36 degrees. This is opposite, and of course this is I can label that hypotenuse. It's also the radius of the polygon. So I want opposite, and I have the hypotenuse. I also have the adjacent. And so in this case I'm going to use sine. So I want opposite, and I have hypotenuse. So the sine of angle 36 is opposite, which is x, over hypotenuse, which is 8. My equation now with only x in it. And so in order to be able to solve for x, what I do is multiply both sides in order to clear the denominator. Multiply both sides times 8. And so these 8's cancel out, and x equals 8 times the sine of 36. I could calculate that and then give a number, round it off and say this is approximately a certain number, but don't do that yet, please, because you want to keep that entire number. That's the true number. If you round here and chop it off, then it's really going to mess things up later. So to find s, the length of the side, I multiply that times 2, because x is half of that length. So s is going to equal 2x, which is 2 times 8 sine 36. And simplifying that down farther, 2 times 8 is, and of course this is the sine of 36, so those things are glued together. The sine and 36 are glued together. Don't multiply 16 and 36. And to find the perimeter, then I say perimeter equals n times s. So 5 again, here's my sloppy 5. That's a 5 times s, which is 16 sine. And now I can go ahead and calculate that for the perimeter, and that's approximately, if I was to round it off to the nearest tenth, that's approximately 47.0. Maybe you want to pause, if you would please pause the video and make sure that you put this into your calculator. In fact, let me give you the buttons, the keystrokes for it. So 5 times 16, and you should be able to get an app on your phone that I want to do times. No, yeah, times. That allows you to calculate, do trigonometric functions. So 5 times 16 times, and then 36, and then sine. And after you hit that sine button, that's going to give you the sine of 36. So after that, you have to hit equals. So there's your keystroke. Make sure that you can get 47.0, or whatever the raw number is, that's rounded to 47.0. Make sure you can get that on your calculator. And now perimeter, and I also have the apothem. Remember, they gave us this length of 6.5 for the apothem, so I can plug that into my equation here. Area equals 1/2 apothem times perimeter. My apothem 6.5, I got that from the diagram, and my perimeter, keep the entire perimeter there. So 5 times 16 times the sine of 36, and yes, you could say 5 times 6 is, what would that be, 80? 80 sine 36 if you want to, but let's just leave it like it is. And now make sure that you can plug this into your calculator also, and you should get 152 point and whatever it is after that rounds up to, or rounds to 0.8. Okay, here we go. Let's do number 4. Number 4, they don't give me anything. What? All they give me is just the length of one side is 7. Huh. And I have to find not only the perimeter of this guy, but also the area. Well, the perimeter actually is not that hard, since they already gave me the side. And how many sides are there? There's a total of 10 there, so n equals 10. So therefore, here we go. All I have to do is say perimeter equals n number of sides times the length side. So 10 times 7, 70. That's easy. Now let's draw your 2 radii here. Draw a center and then 2 radii. And I can calculate the central angle. which is 360 divided by 10. 10 is the number of sides. So each central is 36 degrees. And then blow up my half of that central angle and make it larger so I can look at it and make more sense out of it. And what do I know about this right triangle? Well, I know that this distance here, which we have been calling x, is 3.5, and I get that because each side is worth 7, and so I have half of that side down here, so that makes it 3.5. Okay, so therefore my side length is 7, half of that is 3.5. And then this angle is half of 16, so not 16, but 36. So 36 divided by 2 gives me 18. So this angle up on top is 18 degrees. So I need to find the area. So I need the length of the apothem. Here's my apothem. I find the length of the radius, but I don't care what it is. It's not going to help me. All that I need is just the apothem. So here's my angle, and this is my opposite. If you wanted to label, this is your opposite side. Of course, your radius over here is going to be your hypotenuse. Almost said hypothesis. That's your hypotenuse here. And then A, of course, is your apothem. And then your apothem is going to be your adjacent side. And we're doing this in reference to the 18-degree angle. So I have opposite, and I want adjacent. I have opposite, and I want adjacent. Trigonometric function uses opposite and adjacent. Hey, and if that's a good enough hint for you, and you want to run with the rest of the problem, I would encourage you to do that. Go ahead and pause the video and exercise your own muscle. And now that you have done that, I assume that you have, trust that you have, then opposite and adjacent, that's tangent. So let me take the tangent of this angle, 18. Tangent equals opposite, which is 3.5, over A, my apothem. And now in order to solve for A, one way of thinking about it is you put a 1 underneath the tangent and then cross multiply. Or another way of thinking about it is I want to get rid of the A. I want to clear the denominator. So multiply both sides by A. And when you multiply both sides by A, then my A's are going to cancel out on the right hand side, and on the left, A times tangent of 18 equals 3.5. Now how do I get rid of, I want to solve for A, right? That's my goal. So how do I get A by itself? Well, I divide both sides by the tangent of 18. And so now on the left-hand side, this cancels out, and I'm left at A, my apothem, being 3.5 divided by the tangent of 18. And if you wanted to calculate that and round it off, you get approximately 10.8. But let's just leave it. Let's leave it as that complete number, 3.5 over the tangent of 18. Because that's what I'm going to use when I calculate the apothem, or the area, over here. So remember, area equals 1/2 the apothem times the perimeter. And I can plug in. So again, take that entire number, plug that in for apothem. So 1/2, and I put parentheses around this guy, 3.5 divided by the tangent of 18, and then times 70. Where did 70 come from? Oh yeah, that's your perimeter over here. So now make sure that you can put this into your calculator. All right, you're going to have to do that on your own. If we were to use this 10.8 for the apothem, you would probably get a different number. And wouldn't that be frustrating if the answer for the area was 377.1 that you got, and you're like 0.1 off, and the only reason you got the whole thing wrong was because you rounded your apothem before you put it into your equation. So make sure that you can enter all of this into a calculator and get that the area is approximately 377.0. Number 5, can you do number 5 on your own? Please do. Again, don't be a lazy bum and just sit there and copy this down, make sure that you're able to do it yourself as much as possible. The more you work, the more effort you put into this now, the easier it'll be later. So let me explain this to you. And all that they give me is this triangle, and it's inside of a circle. What? What is that talking about? And they tell me this little distance here is going from the center to the side, and that it is at a right angle. Well, because it's this triangle is circumscribed, remember, a circle going around in each of the vertices of your polygon, it is circumscribing that triangle. Therefore, we know that this is a equilateral triangle, and all equilateral triangles are also equiangular, and so this is a regular triangle. And so I can use my formulas. Very nice. So n equals 3. There's 3 sides to this dude. And so let's take now this half of the triangle. Oh, I guess I did have to draw in. You did not have this originally. But go ahead and draw in from the center to the vertices. So that whole thing there is your central angle. Let's go ahead and calculate that. So your central angle is 360 divided by 3 sides, and that gives you 120. So this entire central angle here is 120 degrees. Now when I take my half of a triangle and blow it up, let's label all the things that I know. This 5 is your apothem, coming from the center and going perpendicular distance to your side. And remember, your central angle is 120. Half of 120 is 60 degrees. So this angle up on top is 60 degrees, and of course this is a right angle. So if the this is 60 and this is 90, and then the other one would be 30. So this is a special right triangle. And so therefore, what I can do is draw another 60 or 30, 60, 90 triangle alongside of it in the same orientation. And you'll remember, when you see 30, 60, 90, you think of 1, 2, square root of 3. And 2 is the largest number there. And so that goes on your hypotenuse. 1, the smallest side, goes across from the smallest angle, across from your 30 degrees. And therefore the other side is square root of 3. And so what did I do here? How did I... Oh, there it is. Yeah, up here. So what I did then is, remember that similar triangles are proportional. The corresponding sides are proportional in similar triangles. And we have 2 similar triangles here. And in order for me to be able to find the perimeter, let's find the perimeter first, I need to find the value of x's. And you'll remember that x is half the length of the side. So if I can find x, then I can find s, the side, and then I can find the perimeter. So here's my proportion. X over square root of 3. So see how, let me use my pen here, how these two sides correspond to each other when I put my pattern in the same orientation as the problem. X over square root of 3. And the only other side that I do know of is 5 in my pattern, and that corresponds to 1 in my pattern. So x over square root of 3 equals 5 over 1. So there's my proportion. To be able to solve for that, you could think of cross multiplying if you wanted to, 1 times x, or you could multiply both sides by the square root of 3. So multiply both sides by the square root of 3, and it cancels out on the left-hand side. So x equals 5 square root of 3. And I'm doing all of this in order to find the length of the side. So the length of the side is 2 times x, which then is going to equal 2 times 5 square root of 3. If I simplify that, s equals 10 times the square root of 3. And now that I have the length of the side, then I can find the perimeter of this regular polygon. And so n was 3. So P equals N times S. N is 3, and my side length is 10 times square root of 3. So 3 times the square root of 3 is my perimeter. And if I was to plug that into my calculator and round it to the nearest tenth, I'd get 52.0. But in order to find the area, I use my formula A times P, A meaning your apothem, P being your perimeter. And remember, use this the clean number, the entire number for perimeter. So 30 square root of 3 plugs in over here for perimeter. And my apothem given to us in the beginning is 5. And so again, make sure that you can put, well, let's see, you should be able to simplify this fraction and these whole numbers. So 1/2 times 30 is 15. 15 times 5 is 75. There's a simplified radical for your area. And then this is pretty simple now to do 75, and then the keystrokes, just to make sure you're okay with that, is 75 and then times, and then 3, and then the square root of a number, and then equals. Because remember, after you hit when you hit the square root button, it gives you just the square root of 3. So in order to get your 130, you want to hit the equal sign at the end, equal button. And then once you round that off to the nearest tenth, you get 130.0. Okay, good job. Thank you for your good work.